Good evening, ladies and gentlemen. Thank you very much for giving me voice. Today, I will talk about comparison of anaerobic digestion and microbial fuel cell for wastewater. The work will be delivered on the basing on our conference article in contemporary science in Gliwice. And the case is telling about this work was made by Dr. Shahan Asis from Mehran University of Science Technology in Pakistan, and entitled was Potential of Microbial Fuel Cell for Bioelectricity Production Using Wastewater Review. This earlier work that discovered future that can also provide ammonia was proven. So here is how the people think 5 years ago about it. So they think that now as still is big problem and new conventional of wastewater are needed. And one is anaerobic digestion and other is, for example, was potential which is used and now which what that apply firstly microbial fuel cell. Problem cost of wastewater directly from agriculture can problems like algal blooms, eutrophication, and technologies, many other which was there, traditional requires much energy and good membranes. So they needed almost 0.5 to 2 kilowatts meter per meter square meter meter square energy is consumed for removing, for example, nitrogen and carbon from that wastewater. And the other cause that electricity energy releases even 0.9 kilograms of carbon dioxide, so increasing gas emitting. So it is important to use anaerobic digestion and fuel cell, which decrease these amounts. And the case was using for sustain. There are a lot of troubles and can be wastewater used for different for municipal and wastewater. As many e-commerce fuel cell is slightly can be used even in domestic way. So why they try to important to enterprise and textile and dyes industry can also be treated for discoloration, pollutant, and electricity production can lead this utilization. Also, dairy milk are big trouble, but mostly biodegradable and can be used. Is often applied for duck fermentation, which is not new, but also more often digestion, which is more better to the anaerobic digestion to methane production. Here is comparison of anaerobic digester and microbial fuel cell, and systematic configuration is upflow slash blanket reactor, internal circulation reactor. There are so many parts now use multi-chamber, and more is going now to imitate the cow and a cow stomach or other ruminant that seems to be more efficient, but more likely now is multi-stage to make in other part the hydrolysis and acidification. And other case is microbial fuel cell. And this microbial fuel cell is usually a single dual chamber. Now we have also membrane system and uh, many use as photocatalytic if to make and to many options. And biocatalysts are food change uh, type which use some food in case anaerobic digestion ammonia because better in case addition for example iron some food can stimulate enzyme responsible for methane on hydrogen production because more hydrogen is giving higher upgrading and higher percentage of in uh, in upflow. And in case of microbial fuels, arsenic mixed culture and input a high and low concentration code. In case of microbial fuel, so we still low because we don't know about ammonia. Now we know about ammonia and acetic acid, but this time was glucose usually, and but the output even for this small was for 1 kilogram of code to production of 1 kilowatt per hour, while in case of microbial fuel cell was even 4 kilowatt hours, and but still was that time power density 2 times higher for anaerobic digestion that microbial fuel cell. After the discovery of ammonia and acetic, this risk would be reversed. The microbial fuel cell was coupled in different compared sequence of so sediment, nuclear flow, wetland, up-to-well continuous flow, sequencing batch reactor and membrane, and the highest membrane bioreactor, and the configuration with membrane bioreactor wastewater was the highest potential of 97%. Very badly was mixed combination with sequencing batch reactor, so that was not then developed. Mostly in wetland and other sediment waste, and also membrane still were even to more efficient, almost 199%. So high efficiency that was there lately more membrane reactor were developed to these reactors and cost as uh, of this using is can produce microvirtual cell up to 3.3 megawatts and overcome of is 50% of capital cost of its lifetime. Uh, we compare activated sledge and other technology. Activated sledge doesn't have revenue which generation system, which anaerobic has have the greater potential for generating net. So many use. Now we know how to regenerate using different nutrients, different nanoparticles, good combination of electrodes. That's time the wasn't known. So this shows that is one technology which can produce some unique features can be, and still as give that more chemical oxygen the demand is can be removed by at that time microbial fuel cell anaerobic digestion. Now we have several combinations with other techniques, and we know that if we use different than water, then microbial fuel cell can generate bioenergy, biohydrogen, and electricity with high amounts. There are some attempts about water, but still high potential of water splitting is big trouble because even 1.40 volts, while microwave fuel up to 0.9. The adding now we consider adding some photocatalysts to make it independent for water splitting by microbial fuel cell to be independent from conventional energy and system. Thank you very much for listening.